Alright, welcome back to the Computational Topology tutorial series. In this video, we're going to actually start implementing some of the stuff that's in the book that goes along with this computational homology. And, well, we have some generic algorithms for manipulating matrices that we have to get out of the way. And these can be found on page 104. So these are operations which, if you've taken linear algebra, you'll recognize. So if we want to, for example, exchange two rows of a matrix, we want a method for doing that, because that's something that we're going to be asking the other algorithms to do, or exchanging two columns, or adding a multiple of one row to another, adding a multiple of one column to another, that sort of thing. So let's implement those. So these are going to be basic algebra, and well, just like with the operators, we have two options here. We can either leave the current matrix intact and return a new matrix. So we could do something like, for example, in the row exchange, if I want to do something like this, and where I tell you, all right, exchange row I and row J, and this will basically return a new matrix, leaving the old one intact. And we could do it that way, or we could say, all right, let me instead just operate this on the current matrix and don't return a new one. I just, I don't care that the rows are going to actually be exchanged with this one, because I'm not gonna go back and need to use the original matrix ever. So we could do it like that. And let's see, does this give us a problem? Because, right, these guys only differ in their return type. However, this one is const, so maybe it'll be alright. Let me see. Yeah, I guess it worked. Alright, so that's fine. And I imagine if I remove this const here, then it'll probably get mad at me. Yeah. Yep. Yep, exactly. So, right, you can't overload a function. Right, these have the same name and the same arguments, but they only differ by a return type. Right, and of course the compiler doesn't like that, because it doesn't know what to assign what definition when it's creating the binary. So we don't want to do that. So if I promise not to change the original matrix, then everything works out fine. So these are a row exchange, and basically, I have one row and another row, and I just want to swap them. And of course, we have to check, whether these two rows actually exist. And the other thing that we can do is we can multiply a row by a value. And so this again is going to, we're going to leave the two options available here, where I can either return a new matrix or just manipulate the current one. And so here I want to specify the row, and then I want to specify the value. In this case, I'm just going to say const t value, and I'm going to promise not to change the current matrix. And again, we want the same thing here, except, right, this one actually just manipulates the current one. So yeah, this is good. And of course, this depends on whatever this type is. Now, eventually when we go on, a lot of this stuff we're going to be using with integer matrices for computing homology. So eventually this will take the role of int. But I'm going to leave it generic just in case we need floating point numbers later. And then the last thing is to actually add a multiple of another row. And again, this takes the row that you want. And let's see. So the way we want to do this is I is going to tell us the row that we want to multiply. J is going to tell us the row we want to multiply with, or add, sorry. And then we need something to actually multiply row J and then add it to I. And similarly, we'll do the same thing without the const, and that should be fine, right? It's not going to give me any issues here. Okay. So those are our basic row operations, and we can do exactly the same thing with columns. So all we have to do is change row to column, and it's that easy. Okay, so let's actually implement these guys. So I'm just going to copy and paste this because it's easier that way. Go down to the bottom here, and let's see. So I need my matrix T colon in front of all these. I'm just going to do that. Alright, and then I need, of course, the template in front of all these guys. Okay, and then finally, just get rid of all these semicolons. There. Alright, so that works. Cool. So now we just have to write these definitions. Okay. So for row exchange, we want to swap row I and J. And in this case, we're going to create a new matrix. So just like everything that was going on here, we need to first create this array, this empty one, and then we have to ask, whether or not. Why is this getting mad? Oh, the const. Huh. How did that happen? That's weird. When I copy pasted, it threw a const in front of this. I don't know why that happened. Let's see. Alright, that should be fine. Yeah. So we have to ask, does row I and J exist? So if I is greater than or equal to mn, or J is greater. Then we need to freak out. So rows, I'm just going to do it like this. I, j, exceed matrix of size there. Okay, yeah. So if either of these are bigger outside of the bounds, then we just want to complain. And then temp is just going to be set to mmat, just like we do with all these other things here. You know, for example, well, let's avoid, but here, right, when we tried to multiply two matrices, if they're not compatible, then we just set this new matrix array to that guy, which is what we did here. All right. Now, if they do happen to work out, then let's see. Then what do we want to do? So we want to go through every row and, well, let's think for a minute. So the way we have this data structure set up is a vector of vectors, right? And each internal vector is a row, right? Or no, is a, yes. Each internal vector is a row. Right? And each element of that row is a column. So what we have to do is, let's see. Well, maybe the easiest way of doing this is just to set this equal to mmat at the beginning. And then go through and construct, you know, this row and this row. Yeah, that's what we'll do. So right, so we're gonna make a oh, okay, yeah, this is pretty easy. So we're gonna make a vector. Since this is in row order form, this is pretty simple. The column one is going to be more difficult. But here, basically all we have to do is say temp I is equal to, right, that particular row. And then temp j is that particular row. And then we just have to swap them. And so we say, oh wait, no, we don't want that to be mmat, temp. Then we just say temp, in fact, we don't even need to do this step. Yeah, we can just say temp I equals mmat j, temp j mmat I. Easy enough. And then we just return that. Done. Okay. So that should work. Yeah. Right. So it's going to be a little more tricky with the column version, because then we have to actually iterate through. Right, because we had row ordered, this particular thing is pretty simple. Okay, easy enough. So then we can just copy and paste this and dump it here. And actually, let me see. Yeah. Yeah, we probably don't want to make an entire new matrix because that's going to be an expensive operation here. And we don't necessarily have to do that. All we have to do in the void case is say, all right, let me just create this guy, and then I'm just going to say mmat j equals mmat I, and then mmat I equals temp. And we don't have to return anything. Good. Right, so in this case, I don't want to create a matrix here, because, right, if we have these giant matrices, that's going to be an expensive operation. So it's much easier to just make a temporary copy of one of the rows and then swap them. Well, here I don't have a choice because, well, I want to make a new matrix, right? I have to, because I'm going to be sending it into the constructor. And if this isn't, if I just put mmat here, that would be a problem, because that would delete ownership of this matrix and give it over to this one. That would cause problems. So we don't. So here it's unavoidable. I got to do it. Here I don't have to. And let's see. The final thing to do is the row multiply, and I think that's going to be similar. Or wait, no. Row multiply and row add. Okay. Row multiply and row add are going to be similar to this. Basically, I can just copy this over. Right, so set that there. And let's see, so row, here I only have one row, so you can get rid of that. And say row I. Exceeds matrix of, I'll leave it. Yeah, I'll leave it like that. Okay. So in this one, we're just multiplying by a value, all the entries in a particular row. So here, what we do is we say we want to go over all the columns in that row and just say temp I j times equals value. And there we go. That's it. Simple stuff. So, right, I'm just multiplying a particular row by a value. And so that row, for every column in that row, I'm just going to do that. Right? And it's easy enough. And in the void case, again, I don't have to make a copy of this, so I can get rid of that. And here I can just say return if there's a problem. And here, I just replace this with mmat. No return. Done. Okay. And then the last one, row add. So this is going to be similar to the row exchange. And so again, I'm going to copy this. Except that we're going to have, yeah, so we want to check that I and j are within this thing. And then what we need to do is, once we've set temp I equal to mmat j, oh wait, no, we don't want to do that. We want to say, right, so we're going to have to create a new going to have to create a new vector whose value is m at j, and then we're going to have to iterate over temp. Let's see, j. We have to iterate over temp and say, all right, temp ij plus equals value times temp j. That'll do it. Right, so here what we're saying is that we're going to iterate over all the columns in row I. And add to them whatever this value is multiplied by the same column in row j. Right, that's what we've set here. Yeah, so this is good. And then finally, we have the other type, which just returns a right, which doesn't return anything. It's just void. So we get rid of that. And here we say just return if that doesn't work. And we don't have to do this. All we have to do is say, oh, wait a minute, this is going to cause a problem. Let's see, do we do this anywhere else? No. Okay. Yeah, obviously I'm passing in j as a value. I can't, right? I don't want to make this j, so that would give me an issue. So I'm going to change that to k. This is still j, right? And likewise here, I also don't want to do that. It's going to be k, and this is going to be temp jk. Oh, but not temp, mmat. And we won't return, and that should work just fine. Yeah. Okay. All right. Well, that's it for the row manipulations. Now we just have to do the same thing for columns. And that's going to be a little more difficult because, well, we don't have this luxury of, you know, the row major order with this stuff. So for the columns, in fact, I think what I'm going to do is I'm just going to copy all of this and then just edit it as I need. So let me get rid of this here. And row add. Right, so this is where it started. So here I'm just going to change all these rows to column. And yeah, so then we just have to go in and adjust each of these. So for column exchange, I have this. Now I actually have to go through and construct these individual columns. So I have to actually iterate unsigned int k, iterate over the number of rows this time, and this temp, oops, these temps, let's see, yeah, so temp ki is going to be set to mat kj. Oh, well, I guess that wasn't so bad. Yeah, so this will do it. Right, so here I actually have to iterate over because it's in row major order. But yeah, That'll do it, right? So this will assign the value in column J to column I of this temp. Right. Okay, that wasn't too terrible. Here, I'm going to have to do the same thing, although I'm going to need, let's see. Yeah, so here I'm just going to have to actually, instead of doing that, here I'm going to have to actually iterate over every row and store a temporary value. So I can do kj is temp, and then I can say mmat kj is mmat ki, ki equals temp. There. Right, so that does exactly the same thing, only acting just on this matrix and not creating a new one. Okay, and then for, let's see, column multiply, and yeah, we definitely need to change this to be m, not n, and these have to be m, and that's got to be m. Okay, and then this is n, I, nope, and we just swap these, j, I. Easy. Alright, and then for the other one, same thing. Right, we switch this for m, and then we say this is n, swap j and I. Done. And then finally for the add one, let's see, this has to be m, it's got to be m, and what are we doing in here? Oh, wait a minute. Right. You can't do that, unfortunately, because this has to be a column now. But I think all we end up doing is putting k here, I there, and then we just say mmat kj. Yeah, that's all it is. And in fact, if we go back up to this, where is it? Row add. We don't have to do this either. There's no reason to create that vector. Instead, we can just say mmat jk. Right. Okay. And I think that's it. We just have this last one here. Yeah, so that's right. And then again, I want to change this to m. Change this to n. And then just swap row and column. There. Easy. Yeah, that's it. Alright, let's see if this actually compiles. We don't get any problems. And it did. So now let's actually test this out. So if we go into our main here, we'll just get rid of this. And alright, so let's test these out to make sure they work. So let's see. First thing I want to do is, make a just a 3x3 identity. Okay, if I print that out, just to see what it looks like. What we have. Okay, good. So let's see what happens when we exchange this row and that row. We'll see if it actually works out correctly. So in the case where I just want to do this operation on the matrix itself, I'll just do that. And if I print then, I get, let's see. Good. Yep, so it actually swapped those. Oh, wait a minute. Right. Is that what we wanted? Yeah. Ah, okay. With the identity, right, swapping the first two, these first two columns and the first two rows give you the same thing. So I was a little confused there for a second. Alright, just to make it clear, let me just put another number there. Make sure that it actually is doing what we want. Yep. So it moved this row to this spot and this row to the first spot. Okay, good. So that worked. And let's see, if we do column exchange, should have the opposite situation happen. And yep. Oh. Okay, the dogs have been silenced. And why am I getting a segmentation fault here? Alright, so let's see. Column exchange. I bet it's an NM swap that screwed something up. Let's see. So K. Alright, so I and J are the columns, and then we say T temp. Oh. Alright. Fix that. Alright. Let's see if it works now. Yay. Okay, good. And alright, now let's try using column add or row add. So let's get rid of this. And we want to add row 1 times -1. Right, so let's see if that does what we want. Yep. Right, so it added to this row, it added -1 times this row, right? And so that just took 1 away from there. Good. And column add, see if that does what we want. And yep, so it took this column, multiplied by -1, and added to this column, right? So we get -1, -1, 0. Good. Okay. And then we need row multiply. Just want to make sure that this works. Let's see. We'll just multiply the first row by -1. Yep, that worked. Of course, C++ has -0 here. That's kind of funny. Finally, column multiply. Yep, does what we want. Right, so that's that. And then just to make sure that our other method of doing this is working, where we actually return a new matrix, let's see. So double M2, and you just want to set that to this. No suitable constructor exists. Huh. Why that no good? Conversion, okay, so it thinks we want the void one. Alright, maybe we have to rethink how this will work. So this thinks that we want to use the void. Probably because it's evaluating this side first. And it automatically thinks that this is just going to be a void rather than the other. Okay. So I think what we're going to have to do is, if we want to set this equal to this, we're going to have to make some adjustments. Yeah, so I don't think that we're going to be able to do it this way. I think the voids can stay functions of the class, but then I think these have to be something outside the class, and they have to take, right, so instead of being a member, it's going to take as an argument a matrix. Yeah, so let me first move all this stuff out to here. And we'll get rid of the voids. And then we'll just shove a constant. Alright, we'll get rid of these constants here. And instead, we'll pass by reference the matrix which we want to actually modify. Yeah, so that's how we're going to do it. And of course we need the template. Damn it. Alright. Yeah, so this should definitely work. And yeah, so we're just going to get rid of these. Okay. And then we're just going to replace what happens in here with our definitions below. So let's see, we have row exchange, that's the first one. So let me just copy this. I'll just cut it. And oops, yeah, we'll get rid of that. And then we'll say this is going to be other. And then here, crap. All right. And J. I. Okay. And we need to replace these other.getIn. Okay. Other.getM. Alright. I'm just going to fast forward here and do the same thing for all these other ones, so I'll be back in a second. All right. So I went ahead and basically did the same thing with all of those other methods. And so now all of these take as argument the other matrix that you want to manipulate. So if we go back in here, this is going to be column multiply, and then we're going to send M in as a reference. Let's see. All right, what's this going to tell me? Of course. Let's see, 152. Huh. Weird. Of course, I did it here too. 161. Alright. Matching function call to matrix double int. Isn't that what this is though? Matrix T column multiply. Because it thinks that this for some reason is an integer. There, will that work? Let's see, now it doesn't like get mat. Do I not have that? Huh, I guess not. Alright, yeah, so let's just add that quick. So we have an array T, and yeah, I don't want to allow it to be messed with, so yay. Did that work? It did. Yep. Because I told this to multiply the new one but leave the old one fixed, right? And so it actually didn't change. But if I print M2, that should have, yep. Right? So that's the one where it actually did adjust. Cool. All right. So all of this is now working, and we have our basic linear algebra methods acting on these matrices. So next time we'll expand this a little more and add some more functions that operate on these things, that use these, and then eventually we'll get to reducing to row echelon form and Smith normal form and all that stuff. And once we have that, then we can finally start computing boundary matrices and figuring out kernels and taking quotients and all that good homology stuff. So I guess until next time, see ya.